Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 3, Section 4, titled Solving Multi-Step Inequalities. By the end of this video, you will have reviewed methods for solving inequalities with variables on one side and solving inequalities with variables on both sides. The solutions reviewed will take the form of and reinforce your knowledge regarding using more than one step to solve inequalities, using the distributive property, and gathering variables on one side. Finally, you will review the skills for resolving real-world inequalities. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you. Objective 1. Solving inequalities with variables on one side. Sometimes you need more than one step to solve an equation. The same is true when you solve inequalities. Just as the equations, you undo addition and subtraction first, then you undo multiplication and division. Okay, let's look at an example. Here's example 1, using more than one step to solve this inequality. So the first thing we're going to do, as I always do, is rewrite the problem. As I say, you learn and understand the problem before you start working it. That way, when you get done on your test and you get to the bottom and you find out, oh, I got that problem wrong, and hopefully it wasn't because you copied the problem wrong or you did the problem, a different problem than what was asked for. So I like to say 7, here in this case, 7 plus 6a is greater than 19. And here's my opportunity to look and say, yes, yes, that's exactly the problem. So what do? Just as we did in equations, the inequality works the same way. You don't worry about the inequality sign at this point. We're solving this as if it were an equation. So the first thing we're going to do is undo addition and subtraction, which means we have to move the 7, the plus 7, from the left side, and we have to move it to the right side, and at that time it will be a negative 7, right? So we're going to add a negative 7 plus 7 plus 6a on the left-hand side, and that's greater than 19 minus 7. And when we do this now, we're going to clear the 7s on the left-hand side because they cancel. And we're going to have 6a is greater than 19 minus 7 is 12. Okay, what's the next step? Well, now we have multiplication. The coefficient of our a variable is 6. It needs to be 1. It needs to be a positive 1. So we have a positive 6. So to do that, we undo multiplication with division. So what we're going to do now is we're going to divide both sides by 6. So I'm just going to draw a division sign here. Both sides divided by 6. The symbol for the inequality is greater than. It does not switch at this point because we did not divide by a negative number. So now we can just solve this. At this point, we have a is greater than 12 divided by 6 is 2. There's our solution. A is greater than 2. If we wanted to solve the look at this to see if it's correct or not, to prove it, check your solution, we can put the 2 in for the a. So we can rewrite that. We can say, I'll just go down here. I'll say 7 plus 6 times 2. Is that greater than 19? Well, now we're really checking to say, is it equal to 19 is what we're looking for at this stage. So we do this, we say 7 plus 12. Is that greater than or equal at this point? Equal to 19. And it is. It is equal to 19. So check. Now let's find out if our symbol is still correct. Did we need to move it or not? So now we're saying here that what? We're saying a is greater than 2, so we can pick 3 if you'd like. So let's pick 3 because it's greater than 2 as a solution, right? So we have our line and you have a is greater than 2. Here's 2. It's a circle on the 2 because it's not equal to 2, it's greater than 2. And this implies that everything here in the direction to the right is greater than 2. So all of these are our solution. I'll put a red line there. All of these are the solution forever to our inequality. So we can pick a 3 because a 3 is right on that line and it is included, right? Because the line went right through it. So that we're going to check to see if our inequality sign is correct. And if it is, if not, means we needed to swap it, right? Well, let's take a look. So now we're going to say, I'll go back to blue. At this point, I'm going to say 7 plus 2, oh, excuse me, 7 plus, I'm reading the wrong spot. 7 plus 6 times 3. Is that greater than? Now we're looking for the greater than 19. And if we do, is 7 plus 18 greater than 19? And the answer is yes, because 25 is greater than 19. That's the solution. Okay, example 1, check your understanding. So solve each inequality and check your solutions. So what do we have? 4 problems. Why don't you pause the video, try these, and when you come back, we'll work them together and see how it turned out. Okay, I'm assuming you paused, you've worked it out. Let's do them together. First thing I'm going to do is I'm going to write negative 3x minus 4 is less than or equal to 14. We're going to solve it as if it were an equation. So we're going to have to move the negative 4 to the other side, make it a positive 4. So we're going to say negative 3x minus 4 plus 4 is less than or equal to 14 plus 4. And when we do that, the 4's will cancel. We're going to get negative 3x is greater than or equal to 14 plus 4 is 18. Now we have to undo the negative 3. And since we have a negative, we're going to be dividing now by a negative on both sides using the division property of inequality. But we're going to be switching the sign, aren't we? So now I'm going to say negative 3x divided by, oops, that was divided by negative 3 is greater than 18 divided by negative 3. And the solution here is x now is greater than or equal to 18 divided by negative 3, which is negative 6. So to solve the check for the solution, this is check your solution, we're going to say negative 3 times what? Negative 6. Negative 6 minus 4 is less than or equal to 14. So now we have negative 3 times negative 6 is 18. And is 18 minus 4 less than or equal to 14? And the answer is yes. 18 minus 4 is 14. So we have 14 is less than, oops, my hand got carried away there, is less than or equal to 14, because it is equal to 14. Okay, and if you wanted to take it that one step farther or further, we're going to look at, we draw a line and we say that x is greater than or equal to negative 6. So here's negative 6 equal to, greater than or equal means there's a dot on that negative 6. And since x, which is all the lines that's going to be part of the line that we're going to draw, the x values, is greater than negative 6. So we're going to draw our line. I'll change it to red. We're going to draw our line in this direction. So that means that we can pick, let's pick negative 5. Okay. So if we put negative 5 in, if we put here, if we put down negative 3 times negative 5 minus 4, is that less than or equal to 14? And when we do that, we're going to see that 15 minus 4 is less than or equal to 14 because 15 minus 4 is 13. 11. 11 is less than or equal to 14. Okay, so since I wrote in this, there's the answer. I'm going to go ahead and erase this because it's in the way. You saw the solution. In fact, I could actually move this up. Why don't I try and squeeze it up a little tighter? I'll leave it in there. So I'm going to say that -3 times -5 minus 4 is less than or equal to 14. And so now I'm going to say 15 minus 4, I'm going to simplify it, the whole thing, is 11, is less than or equal to 14. Yes. Okay? Solution. So let's do the next one. 5 less than 7 minus 2t. So solving it like it's an equation, we're going to get the 2t by itself for now. We're going to move the 7. So we're going to add a -7. So I'm going to say -7 plus 5 is less than 7 minus 7 minus 2t. Okay? So now I'm going to add the -7 and the plus 5. -7 and plus 5, we're going to get -2. -2 is less than, the 7's cancel, -2t. And then to solve for t, we have to undo the multiplication of the -2 to set the t to a coefficient of 1. We're going to divide each side by -2. And when we do that, the sign's going to change. And we're going to get -2 divided by -2. And that's going to be equal to 1. And that is greater than t. So, and the other way to write that, they like us to write it, is t is less than 1. So 1 is greater than t, which means that t is less than 1. So that when you switch the sign, when you switch the variable and the constant sides, you immediately just switch it back. So that's what I did there. And then to check this, we're going to put the solution of 1 in and treat this like an equation. So now I'm going to say 5 is less than 7 minus 2 times 1. And when I do that, I'm going to get 5. It less than, I'm going to put the equal in there, right? So now this is 2. So 7 minus 2 is 5. So this checks. It is equal. And then if you want to check to see if the direction that we switched the direction, is that correct? Well, we can do this. We can draw a number line and we could say that the answer is t is less than 1. So here's 1 and this is t and it's less than, so we got a 0 or a circle on the 1. Here's 1. And t is less than, so that means that all the line, everything here on the line that's red is the less than part. All this is less than 1, right? So that would imply then that 0 is part of the solution set. And if that's the case, I can come back here now and I'll say 5 is less than 7 minus 2 times 0, and that equals what? 5, is that less than 7 minus nothing? Less than 7? 5 is less than 7. So it checks. Let's go to problem C. -8 less than 5n minus 23. Again, we need to get the 5n by itself, so we're going to move the 23, right? Make it a positive 23 on both sides. So we're going to say 23 minus 8 is less than 5n minus 23 plus 23. Using the addition property of inequality, we can now say that we're going to simplify by canceling these 23's. And 8 minus 23 is 15. So we're going to say, so 15 is less than 5n. Okay, so now we're going to divide both sides by 5 because we have to clear the coefficient on this n, make it a 1. So we're going to divide by 5 on the right, and it's still less than because it wasn't a negative. And we're going to divide by 5 on the left, and we're going to get 3 is less than n. I'll draw the line right here. How's that? Here's 3, and it's less than, so it's not including the 3. And the 3 is less than n, so that means that n is greater, because when we do this, we can say that n is greater than 3. We flip the sign when we flip the variable and the coefficient and the constant. So now n is greater than 3, so that means I'll use red like I did before. Everything here is part of the solution. So if this is 3, that implies that 4 is greater than 3. It's got to be part of the solution. So we substitute 4 back into our original equation. We have, and treat it as if it was an equation. See, is it equal? We're going to say minus 8 or negative 8 is less than 5 times 4 minus 23. And when we do this, we get negative 8 is less than 20 minus 23. And is negative 8 less than negative 3? Yes, it is. Okay, and now we pick the 4 and put the 4 in there and try with the 4. So now we're going to say negative 8 is less than 5 times 4. Oh, I did the 5 times 4. Oh, I'm sorry, I already did that. Oh, excuse me. So the answer was and remains negative 8 is less than negative 3. Okay, and if we set this equal to the 3, I guess that's what I missed, that piece. So if I said 8 is minus 8 is less than 5 times 3 and is minus 23. And now I'm going to say that is negative 8 less than 15 minus 23, which is going to be negative 8. Well, this is where we're doing the equals case, right? Because we did the less than case up here. So here's where you're saying that the mathematics is correct, and the upper one here is where we're saying that the direction of the symbol is correct. Let's do the last one now. 5k plus 12 is less than or equal to 2. So we're going to solve that. We're going to move the 12 to the other side. So we're going to get 5k minus 12. Oh, no, excuse me, plus 12 I'll do first. Minus 12 is less than or equal to 2 minus 12. So now we're going to get these 12s canceling. So we're going to get 5k is less than or equal to 2 minus 12, which is minus 10. Okay, so now we're going to divide both sides by 5. Divide by 5, which is a positive 5, so the sign does not change. Negative 10 divided by 5. I should have done the negative sign. And so that equals k is less than negative 2. So if we did our line, negative 2, k is less than, not or equal. So we got the or equal, or equal. So now it's a dot. And k is less than the negative 2. So that means all of this stuff, I guess I should have done it in blue or whatever. It's all of these, right? These are all, forever in the leftward direction. So negative 3 now is a check that we could use to determine if our sign is correct. The negative 2 is if we did our math correct. So we're going to substitute in, we're going to say 5k, which is, in this case, negative 2, plus 12. Is that less than or equal to 2? And when we do this, we get negative 10 plus 12 is equal to 2. So 2 is less than or equal to 2. That's correct. And if we do substitute in the negative 3 now, we're going to say 5 times negative 3 plus 12. Is that less than or equal to 2? And when you do that, we get negative 15. Negative 15 plus 12 less than or equal to 2. And negative 15 plus 12 is negative 3. Negative 3 is less than or equal to 2. And is that true? Yes, negative 3 is less than, in this case, 2. So there's your solutions. Okay, example 2. It's a real-world problem that we're going to look at. The school band needs a banner to carry in a parade. The banner committee decides that the length of the banner should be 18 feet long. A committee member drew the diagram at the right. You see this diagram is over here on the right hand side. It says 18 feet by W over here, 18 feet by W, right? So the committee member drew the diagram at the right to help understand the problem. What are the possible widths of the banner if they can use no more than 48 feet of trim? So first, let's try to convert this problem into some words that we can write and change into an equation. Since the border goes around the edges of the banner, use the perimeter formula. Perimeter, P is equal to 2 times L plus 2 times W. 2 times length plus 2 times the width. So here it is. Twice the length plus twice the width is no more than, because they have 48 feet, they can't use any more than 48 feet. No more than the length of the trim, 48 feet. Okay? So when we write that as the equation, now we're going to get 2 times 18 because they said the banner, they want it to be 18 feet long. So it shows in the picture, 18 feet. So 2 times 18, that's the length, plus 2 times the W. We don't know the width. We're trying to find out what is the maximum width we can have based on this criteria. And it's no more than, so less than or equal. It could be 48 feet. Can't be more than 48. So that means it could be 48 or less. Less than or equal to 48. The trim length of 48. Okay, so there's our equation. I'm going to write the equation now. 2 times 18 plus 2W right here is less than or equal to 48. So we're going to simplify that. 2 times 18 is 36 plus 2W is less than or equal to 48. Now we have to move the 36 to the other side, right? We have to subtract 36 from both sides because we have to get the W alone by itself on one side and the constants on the other. So we're going to subtract 36 right here, 36 being subtracted from each side. And that when we simplify that, we get 2W. That's our 2W right here. 2W is less than or equal to 12. 48 minus 36 is 12. Now we have to get the 2 away from the W, right? We have to unlock or unzip or whatever you want, undo the multiplication of 2 times W. And to undo multiplication, we use division. And to do that, we said 2 divided by 2 times W is less than or equal to 12 divided by 2. We divided both sides by 2. And when we did that, we ended up with W is less than or equal to 6. So the banner's width must be no more than 6 feet. So 6 feet or less. Okay, example 2, check your understanding. Directions here. Make a second banner. The committee decided to make make the length 12 feet. Okay. They have 40 feet of a second type of trim. Write and solve the inequality to find the possible widths of the second banner. Okay. So what are we going to do? We're going to pause and let you do this on your own. It's pretty much exactly the same as the previous slide. So when you come back, we'll move on. I'll wait. Okay, I'm assuming you've completed that task and we're ready to move on. So make a second banner. The committee decides to make the length 12 feet. They have 40 feet of a second type of trim. Write and solve the inequality to find the possible widths of the second banner. So what do we know? We know that we have a 12-foot length, right here, 12-foot length, and it's 2L, the perimeter is 2L, right, plus 2W, same as before. So 2L, 2 times 12, plus 2W, because there's two widths on the banner. We don't know what the width is, and it has to be less than or equal to 40 feet. Our new, where is the 40? Here it is. Less than or equal to 40 feet, because that's the maximum amount of trim they have of the new trim or the second trim. Simplify, we get 24 plus 2W is less than or equal to 40, our new length of trim. 24 minus 24, to clear the 2W of the mathematics, the plus 24, we're going to subtract 24 from both sides. So we're going to get 24 minus 24 plus 2W is less than or equal to 40 minus 24. Well, you know that the two 24's canceled, so that's 0. So we get 2W is less than or equal to 16, because 40 minus 24 is 16. So now we have to get the W by itself. And to do that, we have to undo the multiplication, which is the multiplication of 2 times the W. And we undo multiplication by division. And right then, we're going to divide both sides by 2. So here we have 2 divided by 2 times W is less than or equal to 16 divided by 2. Okay, when we simplify, W is less than or equal to 8. So there it is. The banner's width must be 8 feet or less. Okay, example 3, using the distributive property. So again, this is just like we did back in equations, right? It's just an inequality, but we're going to treat it like it's an equation, unless we have to eventually divide by or multiply by a negative number to clear the coefficient. And if that happens, then we're going to go ahead and flip the sign, remember? But let's take a look at this. So we're going to solve this inequality. And we're going to start by rewriting it. 2 times t plus 2 minus 3t is greater than or equal to negative 1. So look at that, we have two t's in here, so we're going to end up combining them. So now we're going to do that. We're going to write 2 times t, because we're taking care of the distributive property here, plus 2 times 2 is 4, minus 3t is greater than or equal to negative 1. So now we can combine our t's. We're going to combine like terms here. So we have 2 minus 3 is negative t plus 4 is greater than or equal to negative 1. So now we're going to undo the addition that we have with the plus 4. So we're going to say minus t plus 4 minus 4 is greater than or equal to negative 1, and that minus 4. And when we simplify that, we're going to get negative t, the 4's cancel, is greater than or equal to negative 1 minus 4 is negative 5. And now we have to clear the negative sign from the t. And what do we do then? Of course, you know, we're going to multiply both sides by negative 1. So negative 1 times negative t is less than, I switched it, less than or equal to negative 5 times negative 1. Okay, so now the negatives cancel, so I get t is less than or equal to, and the negatives cancel, 5. So there's the answer right there. T is less than or equal to 5. Okay, example 3, check your understanding. Directions, solve each inequality. Check your solution. Okay, how about this? Problem A, you're going to do a 4p plus 2 times the quantity of p plus 7 is less than 8. So as what you see here is we have this distributive property in these questions. So go ahead and stop it. That's one of them. You can do the other ones. Um, I don't need to read them to you. So go ahead and work these, and when you come back, we'll move on, okay? Okay, now that you're back, let's go ahead and do problem A, the one I read. So I'm going to rewrite it. 4p plus 2 times the quantity p plus 7 is less than 8. Okay, so first thing we have to do is clear the distributive property. The parentheses have to be taken care of, right? We have to resolve this multiplication right here. So we're going to have 4p plus 2p, 2 times p, plus 2 times 7, 14. And that is less than 8. Now combined like terms, we have a 4p and a 2p, so we're going to have 6p plus 14 is less than 8. We have to clear the 6p to live by itself, so to speak, so we have to move the 14. So we're going to say 6p plus 14 minus 14 is less than 8 minus 14. Simplify, we're going to have 6p is less than negative 6. So in order to clear this multiplication, to undo the multiplication associated with the p, the coefficient 6, we're going to divide both sides by 6. And by doing that, we're going to have 6 on this side and 6 on this side. We did not divide by a negative number, so our sign will not change. So we're going to have p is less than negative 1. Okay, so now to check it, if we put negative 1 in our equation up top, we're going to say for p, we're going to be 4 times negative 1, all right, plus 2 times negative 1 plus 7 is less than 8. Well, we're solving this as if it was an equation because we want to see if the math was correct. So it could be an equal sign right here instead of the less than sign because we want to see if this side on the left equals the side on the right. So now we have negative 4 minus 2, right? Minus 2 plus 14 is less than 8. And is that true? Minus 2 minus 4 is minus 6 plus 14 is 8. 8 is, in our case, equal, we're going to say equal to 8. That's good. Let's do the next one. 15 is less than or equal to 5 minus 2 times the quantity 4m plus 7. Okay, and we're going to have to resolve the distributive property first before we move on. So we're going to write this as say, we're going to say 15 is less than or equal to 5 minus 2 times 4m is going to be minus 8m. Minus 2 times 7 is minus 14. Okay, so now we have a 15 on one side and we have two constants with the 8m, so we're going to combine like terms here. So now we're going to say 15 is less than or equal to 5 minus 14 is 9, right? Negative 9. Negative 9 minus 8m. So we're going to move the negative 9 to the other side. So we have negative 9 plus 15 is less than or equal to negative 9 plus, oh, sorry that. I have to get rid of the negative 9 and make that a positive. Excuse me. I just caught my mistake there. We have to multiply both sides by, not multiply, add positive 9 to clear the negative 9. So positive 9 plus 15 is less than or equal to positive, in our case, negative 9 plus 9 minus 8m. So now these 9's here cancel, and we have 9 and 15 is 24. Is that less than or equal to, um, did I get everything picked up? Minus 8m. Okay, so now I have 24 less than or equal to negative 8m. And since I have a negative to get rid of, the sign's going to change, right? So now we're going to divide both sides by negative 8. Divide by negative 8. Change the sign. Minus negative 8m divided by negative 8. And that equals minus 3. 24 divided by negative 8 is greater than or equal to m. Or you can write it the way they like you to write it, with the variable first. It's a standard form. So it's, or I'm going to say m is less than or equal to negative 3. You have to switch the symbol when you flop the symbol and the number. When you flip them like that, in our case, we put the negative 3 on the right-hand side and the m on the left-hand side. Okay, so m is less than or equal to negative 3. That's the way to officially write it. So now negative 3 is our solution. We're going to check this to make sure our math is correct. Okay, in doing so, we're going to say 15 is less than or equal to 5 minus 2 times 4 times negative 3 plus 7. Okay, and now when we simplify this, we're going to get 15 is less than or equal to 5 minus 2 times negative 12 is plus 24, right? And then it's negative 2 times 7, which is minus 14. Combine like terms again. We have a 5, oh, a 24, and a 14. We have 10 plus 5 is 15, because 24 minus 14 is 10, plus 5 is 15, and we have 15 is, well, in our case, equal to 15. Okay? The next one, 8 greater than 3 times the quantity 5 minus b plus 2. So we're going to clear the distributive property first. 8 is greater than 15 minus 3b plus 2. So now we have some like terms here. So we have a 15 and a 2 makes 17. So 8 is greater than 17 plus minus 3b. We're going to move the 17 to the other side. So we have to subtract 17. So we have negative 17 plus 8 is greater than 17 minus 17 minus 3b. So now we have the minus 17 plus 8, right? Okay. And on the one side, and we have is greater than 17 and 17. They're going to cancel. Okay. So we have a negative 17. We're going to add 8 to it. We're going to have what? Negative 9, right? So negative 9. Oh, well, no, we're not adding negative 9 to it. We're just going to resolve this. It's going to end up with negative 9, excuse me. So negative 9 is greater than negative 3b. And now to clear the negative 3b, we're going to divide both sides by negative 3. Negative 3. But when we do this division by negative 3, we have to flip the sign. It's now flipped. So we have 3 is less than b, because the negative 3's cancel on this side. 3 is less than b. So now we can put a 3 back in the top. So we have 8 is greater than 3 times 5 minus b, and b is a 3 plus 2. So is 8 greater than, or we're checking for the equals actually, right? As if this were an equation. So is 8 equal to 15 minus 6? Oh, is that 15? Oh, excuse me, not minus 6. 15 minus 9 plus 2. And 15 minus 9 is 6 plus 15. 8 is 15 minus 9 is 6 plus 2. And that is equal 8 is equal to 8. Sorry for the pause there for a second. Okay, so there's our solution for that. Okay, objective 2, solving inequalities with variables on both sides. So many inequalities have variables on both sides of the inequality symbol. You need to gather the variable terms on one side of the inequality and the constant terms on the other, just like we did with the equations. Okay? Okay, example 4, gathering variables on one side of an inequality. So in this particular problem, we have 6z minus 15 is less than 4z plus 11. So there's z terms on both sides, and we're going to have to get them to one side and the constants to the other. So let's do it. So I'm going to write the equation out. I'm going to say 6z minus 15 is less than 4z plus 11. So let's start. We just move the variable term first. So we're going to subtract 4z from both sides is what I'm going to do. So 4z minus 4z plus 6z minus 15 is less than 4z minus 4z plus 11. So now these z terms erase, and minus 4z plus 6z is 2z, so 2z minus 15 is less than 11. So we have to subtract the 15 now, or move the 15 by adding 15 to both sides. So now we're going to get 2z minus 15 plus 15 is less than 10 plus 15. So when we simplify this, we're going to get 2z is less than 25. Less than 10 and 15 is 25. Oh, there's an 11 here, not 10. Sorry. Sorry. I have to fix this. It's an 11, not 10. Not 10. Sorry. So it's 11 and 11. So it's 2z minus 15 is less than 11. Here's the 11 up here. See it? Then 2z minus 15 plus 15, they're going to cancel. And it's less than 11 plus 15 is now, oops, fix this one too. Oop, there we go. 26. Okay, so now we have to clear the 2 by undoing it, and we undo a multiplication by a division. So 2z divided by 2 is less than, since it's positive, we're not changing the sign, 26 divided by 2, and therefore we have z is less than 13. There's our solution. Okay, example 4, check your understanding. Solve this inequality, which says 3b plus 12 is greater than 27 minus 2b. So let's give this a shot, right? So go ahead and pause, try it, come on back when you're done, and we'll do it together. Okay, I'm assuming you had time to pause the video and give this a try. So what do we have? Let's see, we have 3b plus 12 is greater than 27 minus 2b. So the first thing we're going to do is we can, well, either term, we have variables on both sides and constants on both sides. We can move either one we want. So let's say we're going to get rid of the 2b on the left-hand side, right hand, and put it to the left by adding 2b. So 3b plus 2b plus 12 is greater than 27 minus 2b plus 2b. Okay, so now we're going to simplify this. The 2b's on the right-hand side cancel, and we have the 27 left. So on this side, we have 2 and 3, so we have 5b plus 12 is greater than 27. So now in order to solve this, we have to move the 12 to the other side, and we're going to add a negative 12 to do that. So we have 5b plus 12 minus 12 is greater than 27 minus 12. And when we simplify this, we end up with 5b is greater than 27 minus 12 is 15. And now we have to undo the multiplication of the coefficient times the b, which is 5 times b. And we're going to do that by dividing by 5. So we're going to say 5b divided by 5. And it is a positive number, so the symbol will not change. 15 divided by 5. And 5 divided by 5 over here gives us b is greater than 3. Check your solution. So we're going to go back over here and we're going to say 3b, 3 times 3 plus 12 is greater than 27 minus 2 times 3. So 9, simplifying 9 plus 12, is that greater than, no, in this case we're checking for equal to, I'll change it fully to an equals. Because when you're doing the substitution like this, you're trying to find that you've done the mathematics correct. So 9 plus 12 is what? Is 21. And 27 minus 6. And is 9 plus 12, 21, equal to 27 minus 6, 21? Yes, it is. Okay, example 5, we're still going to solve a multi-step inequality. So that just means that we're going to be multiplying in a couple places and shifting numbers around. So multi-steps, it's more than just moving one item or two items. So let's give it, it'll be fun. Let's do it. So we're going to write it out. Minus 3 times 4 minus m is greater than or equal to 4 times 2m plus 1. So we have two distributive properties to resolve here. So we're going to say minus 3 times 4 is minus 12. And it's minus times a minus, plus 3m is greater than or equal to 4 times, should be 8m plus 4. Okay, so now we've eliminated the distributive properties, right? So now we have 1m on each side and a constant on each side. So let's move the 12. So now we're going to have minus 12 plus 12 plus 3m is greater than or equal to 8m plus 4 plus 12. Combined terms, the 12s here cancel each other out. So we have 3m is greater than or equal to 8m, and 4 and 12 is 16 plus 16. So now we're going to have to move the 8m. Okay, so now we're going to subtract 8m from each side. So minus 8m plus 3m is greater than or equal to 8m minus 8m plus 16. Simplifying, we're going to get rid of the 8m's on this side, and we're going to have negative 5m is greater than or equal to 16. Okay. And when we do this, now we did get 16. Yep, 16. So now we're going to divide both sides by 5. So we're going to divide this side by negative 5. And now we switch the symbol. And we have 16 divided by negative 5. And what do we get? We get m is less than or equal to 16 fifths negative. Okay, example 5, check your understanding. So what we'd like to do is pause the video and go ahead and try this on your own. Be careful, it is a tricky problem. Think about what you're writing, and as you're writing it, um, go ahead and solve this inequality. And if you have trouble checking your solution, don't worry about it. Just come on back and we'll work on that together. Okay? So I'll wait for you. Okay, I'm going to assume you're back, so let's go ahead and let's solve this. Let's solve the inequality first. So we're going to say that negative 6 times x minus 4 is greater than or equal to 7 times the quantity 2 times x minus 3. So now we're going to remove the distributive property symbols here. So we're going to say negative 6 times x is negative 6x. Negative times negative is positive 24. Oh, how did I get negative? Yeah, negative times, that's correct. Is greater than or equal to 7 times 2 is 14x minus 21. So we're going to combine the like terms. So we're going to say, in this term, we'll do the constants first. So we're going to do negative 6x plus 24 minus 24 is greater than or equal to 14x minus 21 minus 24. And now we're going to combine like terms so that the 24s will cancel. We have negative 6x is greater than or equal to 14x minus 45. Okay, so now we're going to get the x's together. So we're going to subtract 14 from both sides, 14x. So negative 14x minus 6x is greater than or equal to 14x minus 14x minus 45. The 14x's cancel each other out, and we add the 6 and the 14x on the left-hand side, and we're going to get negative 20x is greater than or equal to negative 45. So we have to divide both sides by the negative 20. So we're going to divide this side by negative 20 and this side by negative 20. And when we do that, the symbol will change directions, and we'll end up with x is now less than or equal to 9/4. So there's the solution. Now we're going to check it. So to check it, we'll write over here, I'll write the problem again. Negative 6 times x minus 4 And we're gonna check for the equals, right? Did, did we do the math correctly? So equals 7 times 2x minus 3. So let's start with the left-hand side and just solve this side by itself. So we're going to say negative 6 times 9 fourths, right, minus 4. So we have negative 6 times 9 fourths, and I can say minus 16 fourths. And when I do that, I get negative 6 times 16 minus 9 is 7, right? So I take the sign of the largest number. So it's negative 7 fourths times 6. 6, so that's equal to negative 6 times negative 7 fourths is 42 fourths, which is equal to 10 and a half. Okay. Now let's try the right-hand side, see what we've got. So we're going to say 7 times the quantity, 2 times 9 fourths minus 3. So let's do the inside here piece. Leave the 7 alone. So 7 times the quantity. 2 times 9 fourths is 18 fourths. And it's 18 fourths minus 3. Okay. And we can say 7 times 18 fourths. And I'm going to rewrite that. 18 fourths is equal to what? I'll make this easier. 18 fourths I lost track of where I am. 18 fourths. Oh, here's my pencil. So 18 fourths. Well, let's just do it. 18 fourths minus 12 fourths minus 18 fourths. Sorry for pausing like that. Minus 12 fourths. And that is 7 times 18 minus 12 is 6 fourths. And if we multiply this out now, we get, and that is equal to 42 fourths. And 42 fourths is equal to 10 and a half. And as you see here, 10 and a half from here is equal to 10 and a half from on this side. So that we've done that correctly.